Hi everyone, and welcome today to our webinar. Thanks for joining us. Today we're going to be talking about Fusion 360, and this particular webinar is sort of the first, or perhaps you might consider it the second in a group of sort of 4 or 5 webinars that we're planning to do over the coming months. Today is going to be focused specifically on general part modelling. So my name's John Pitcher. I'm from A2K Technologies, and it's great to be able to present for you today on one of the fantastic applications that Autodesk have released for computer-aided design, or CAD type applications. So yeah, thanks for joining us. We'll get straight into the material shortly. So as I mentioned, this particular webinar is sort of fits in with a number of others that we've done over the past, and that we plan to do over the coming months, all going well. So today we're going to be looking, like I said, at general part modelling. So just 1 or 2 things about A2K before we get into the Fusion side of things. So A2K are a technologies provider, and we're all about fostering innovation through our consulting and training activities. A2K plays a vital role in helping the infrastructure, building, mining, construction, architecture and manufacturing industries reach their full potential by delivering complete technology solutions and support services such as education, consulting, IT and managed services. So we're working with visionaries to shape the future of design and in turn enable them through innovation to minimise the risk, improve productivities and achieve excellence. A2K is considered the business partner of choice and trusted advisor by our vendors and clients. We partner with major software and hardware vendors to meet our clients' technology needs. We strive to exceed client expectations by understanding their challenges and delivering solutions through experience and innovation. We work with clients and companies of any size, both nationally and abroad. Just a couple of things about me. So as I mentioned, my name's John Pitcher. I've been involved in mechanical engineering for the bulk of my working life. I started my working life as a fitter machinist and did a trade in fitting and turning. Since then, I've been working with a number of companies in the CNC space. So I spent 10 years or so in numerous aspects of CNC design. So manufacturing various components for hydraulics and pneumatics industries. But yeah, for the past 13 years, I've been connected mainly with the Autodesk line of products, where I train people to use software like Fusion, Fusion 360. Also, I train AutoCAD, Inventor, and I also dabble a little bit in the CAM side of things. One of the other roles that I've adopted over the last 18 months or so is more involved in the additive manufacturing side of things with 3D printing. So A2K have quite a line of 3D printers that we sell, not so much for printing trinkets, obviously, but for printing production-ready components. So just 1 or 2 things about the webinar today before we launch into the material. With regard to your Zoom meeting panel, you will notice there's a Q&A section there if you'd like to pop any questions in, if you have any queries or questions about what we're discussing today, and we'll have a few minutes towards the end of the session just to hopefully cover any of those questions off. Okay, so what we'd like to do today, this is sort of a starting type webinar, I suppose, in one sense, in that we're going to be looking at some fairly basic things, but effectively as well, just before we have a jump into Fusion, I do plan to go into Fusion, all going well, and run some demo on sort of general part creation and how we can use the various tools within the Fusion interface to work with what we're doing. But as I said, Fusion itself is a relatively new CAD product. It's an Autodesk application that was sort of developed in the late 90s and early 2000s, obviously still under development as well as we move forward. The main thing about CAD applications. And look, there is a number of CAD applications that go back 10, 20 years beyond that. So AutoCAD obviously was one of the first developed CAD systems, which was developed in the late 70s and early 80s, and is still quite popular today. So so why is it important that we talk about that? And I guess when AutoCAD was developed, most of us were still working with dial-up internet. For those of you that have the pleasure of remembering that, dial-up was obviously a whole lot slower, and we weren't working in a cloud type situation as we do with today's applications. Certainly things like NetBank and all those other cloud-based orientations and the tools and applications that we use today weren't even thought of back in the 1970s. So certainly engineering and all applications really have moved forward at a rate of pace in the last 10 to 20 years, obviously because now we have a much greater bandwidth, and we can work with numerous other tools for collaborating and sharing information and data over the cloud. So Fusion 360 was, I guess, developed as a tool that allows us to work in cloud space and save files up to the cloud and very quickly and easily collaborate with other users and work in that sort of situation. The future of making things is a topic that Autodesk have been talking about for some time, and really when we talk about the future of making things, I guess it's what we're seeing in the world happening today, isn't it? There's a lot of changes to industry. We need to obviously move forward with the way the technology of today's world is moving, and Autodesk have done a great job of keeping up with and even being a market leader in these areas because of their CAD tools that are available to us and allow us to work with that. So really, I guess what I'm trying to say is the fact that Fusion is a fairly new type CAD application means that when the developers started developing Fusion, obviously they did it with the whole concept of cloud collaboration in mind, and working with all things cloud-based to enable us to work with that. So there's a great deal of power in what we can achieve within Fusion because it's so interconnected with cloud services, not just for storage, but also for processing. For instance, if you want to do a render, you can either choose to render on your local machine within Fusion, which could take, for a large size render, it could take anything from 2 hours to 22 hours if you've got something that you want to render at a very fine detail. But effectively, we can also render on an Autodesk server and use a cloud service to do that. And basically, it takes 1/10 of the time. So effectively, you can upload a render process to a cloud server and basically allow Autodesk servers to produce that render for you. So that's just one example of how we're connected with the cloud and the benefits of working with cloud connectivity in that sense. And we'll perhaps cover that off in a later webinar as well. We'll go through and talk about some of the other cloud tools that are offered as far as Fusion 360 goes. So Fusion 360 is, like I said, it's a slightly newer CAD application than the likes of AutoCAD or even Inventor. It's much more cloud orientated and allows us to work collaboratively within a situation. And it also gives you the benefit of being able to manage your data a lot more concisely, I guess, via Autodesk cloud services. So when we talk about Fusion 360, what is it? Well, basically, it's a cloud-enabled CAD software package. It's it's obviously a lot more than that as well, in the sense that Fusion 360 also has tools for generating toolpath. So if we want to do some CAM type processing, we can do that within Fusion. As I mentioned before, doing things like realistic renders, we've got all those applications as well, plus a bunch of other tools that effectively allow us to work within a very powerful CAD system that is connected or interlinked with the with cloud systems and cloud operations within the Autodesk server environment. Now, you may have heard of some of the other 360 tools within the Autodesk suite of products. You might have heard of BIM 360. You might have heard of AutoCAD 360. And look, there's many tools in the AutoCAD workspace that do have this 360 branding on them. And effectively, those tools are all interrelated to the concept of working in the cloud. So if you run AutoCAD 360, for instance, on a desktop type machine or on a laptop or even on a Surface or something of that nature, it's linked to a cloud server. So most of the 360 applications are actually cloud dependent. However, Fusion is slightly different in the sense that we install an application locally and we can actually run it in offline mode. And I'll show you how to do that in our live demonstration shortly. So we can actually operate free from the internet. We can save our files to our local drive if we like and stay off the internet for a period and work with local files if that's what we want to do. So basically with Fusion, the other big benefit is that it can function natively on a Macintosh machine as well. So if you're a Mac user, you might be pleased to hear that Fusion will actually function natively on a Mac as well as on Windows type systems. And it's one of the only systems to do that. So it's quite a clever tool that it allows us to work natively on Mac or Windows type operating system. So like I said, it's much more than a CAD system. Like I said, it includes a CAM workspace. We've got simulation tools as well for doing FEA studies and for various other aspects of the engineering type workflows that we might need to do. We can also create sheet metal components and flat pattern those. We can animate exploded assemblies. We can do a range of different things with that, including working with T-splines and NURB surfaces. So for those of you that want to create some more ergonomic shapes, and we will touch on this a little later on in our demonstration as well, we've got the option to work with T-splines and NURB surfaces, as I mentioned. So some of the main features of the Fusion interface, and I have actually covered this off, and I've just put there a little screen grab of a webinar that I did a couple of months back, and you might like to look into this one if you're interested in the data management and collaboration side of Fusion. So back in December, I did actually run a webinar on this, specifically focused on aspects of that and going a bit of a deep dive into the data panel within Fusion 360. So look, please feel free to jump in and watch that little, that was about a 40-minute presentation that I did specifically on the collaboration and data management side of Fusion. So you may like to take a look at that one if perhaps that's a bit of a precursor to this particular webinar in that sense. But yeah, look, feel free to jump on and have a look at that. If you'd like, I can put the link to that in the chat later on at the end of this particular session. But yeah, basically with Fusion, obviously we traditionally, or we can work within a purely cloud storage type environment. The big benefit of that is if you're sitting in an airport somewhere and you've got half an hour to wait for a flight, although not many are perhaps doing that just at the moment, but certainly you can open Fusion and work anywhere you like on pretty much any device. So you can log in on either, like I said before, either a Mac or a Windows PC. You could go to Fusion on a Surface Pro, for instance, or whatever it might be. Log in with your credentials and it will give you access to your files that are stored in the cloud. So rather than having to VPN into a server or something of that nature, the benefit of this is that your documents are stored in the cloud, and certainly there's some massive benefits in being able to access them effectively from any particular location, as long as you've got an internet connection. So I guess it's much like using Dropbox or Google Drive or any of those tools, but like I said, it is a slightly more automated functionality where it sort of all happens in the background. The other big benefit of how Fusion does this is it manages all your revisions as well. So whenever you do a file save or make a change to a file, Fusion defaults to revisioning up the file to the next release. And I'll certainly touch on that in a moment when we go through our demonstration. But I did, as I said before, spend a little bit of time on this one in my previous webinar. And we'll probably touch on this in future webinars as well. So the other thing we can do as well is cache our working files to our local machine. So there is methods of being able to do that as well. So you can actually work with that also. Now, a lot of people are cautious about using web-based applications or web connected applications because of security issues and things like that. However, there is quite a lot of information on the internet about how Autodesk are trying to combat this. They do have quite a lot of detail. I have an extra slide on this, but I can send you some information on this as well if you'd like, with regard to how they the various ISO standards. So they have compliance with numerous ISO situations where they comply with the various aspects of cloud security. So if you'd like to read up on that more, you could go to that link at the bottom of the slide on your screen at the present, just to sort of see how Autodesk manage all this. There is a number of ISO standards for data management and cloud storage, and you will find that Autodesk ticks all those boxes. So it is quite a secure environment. I don't think you need to be too worried about security in that sense, and keeping your data safe is obviously a priority to everybody, but yeah, certainly being able to work with that data is quite important. Okay, so let's jump into Fusion now. I'm going to open up Fusion and just have a quick run through of a couple of little examples for you, and just run through the basics of working with simple part modeling and just some of the concepts with regard to that. So I've just opened up my Fusion interface here. Hopefully everybody can see this okay. So basically within Fusion, it's a very traditional CAD system in the sense that we've got a bit of a menu across the top, some drop-down menus here with some extra tools and various other aspects for the Fusion interface. As I mentioned before, the data panel, this little icon in the top left here, which I think our American friends call a waffle. But basically, the data panel is where we can access the various data that we might be working with, and pulling up various information. So in the data panel, we can set up numerous projects. So we can set up a range of projects that are basically for various parts of our modeling sequence, and inside those projects we can set up a number of folders, and then we can save our files within those folders. So effectively this is like working on your C drive, if you like. So all this happens in the background, and basically what the idea is that this is all collaborative and effectively works in the background. You don't have to worry too much about doing anything with that. So what I want to do today is just talk about this little wheel assembly that I've got here. It's sort of like a caster wheel. But I think I've got the assembly open here. So I've got a wheel here sitting on a couple of brackets and a mounting plate. And as you can see in Fusion, we've got a browser, a bit like most of your CAD software has these days, with a browser with some various information in it. And in here, I've got the various components of my assembly. So we'll go into a little bit more detail on this later on, but effectively you can see there, this assembly is made up of a base plate, which is this part here. We've got a couple of brackets, so bracket 1 and bracket 2 in position here. We've got an axle, we've got a wheel, and we've also got some socket head cap screws that are placed into our assembly there. So what I thought we'd do to start out, like I said, today's webinar is really designed to give you a bit of an idea about working with simple part modeling and just how to use sort of a Fusion's interface for creating simple parts. So what I thought we'd do as a bit of a starting point is maybe just model up this base plate here. So the plate you can see at the bottom. So again, yeah, we just turn all these other components off so you can see the part that we're going to be working with specifically. So what we'll be doing is just creating this base plate part, and I'll be working through that particular process with you. So like I said, the assembly itself is made up of a series of other components, but I thought just as a starter, and look, if you've got Fusion open, please feel free to run through this with me. I'll go through it at a reasonably slow pace so everybody can keep up. Yeah, I thought we'd just model that up. So before we started, I did actually jump in and grab a quick drawing of this particular part. So this is some of the dimensions of the base plate. So you'll notice it's 135 by 78 millimeters. It's got 12 mil radiuses on the corners here. It's 16 millimeters thick. And we've got a couple of little cutouts, and I might come backwards and forwards from this drawing as we create this part, just so we can see and manufacture this to some specific sizes. So effectively what we want to do is end up with a component that looks a bit like this, and I'll work through that with you now. So when we open a blank file in Fusion, and I've been jumping between these tabs at the top here. So these are the files that I've got open presently. I've got 5 particular files open. I've got a drawing file here. I've got the part that we're going to model up here. I've got a blank file, which is what we're going to be working in now to create that particular base plate, or this particular brown part that you can see over here. So when we start out with creating parts in Fusion, there's effectively 3 different ways of doing it. And so what I thought we'd do today was just start with the basics and effectively move into a couple of other processes and have a quick look also at some freeform modeling techniques if we've got time. So that's sort of a bit of a plan of what we'd like to tackle this morning. So like I said, if you've got Fusion open, please feel free to follow along. Basically what we're going to do is start off with a rectangle. Now within the Fusion interface, when we start off, you'll notice we've got this create menu where we've got a number of what we call primitive shapes. So down here I've got the option to create a box, a cylinder, a sphere, a torus, a coil, or a pipe. Now all of those particular primitive shapes are good starting points for creating a particular item. And one other thing when you're 3D modeling, there's always more than one way of doing things. For instance, if I can just give you another little example, if we were to create the wheel, for instance, there's again a number of different ways that we could do it. We could start off with a cylinder. So we could use our create and cylinder tool to create the outside diameter of our wheel, and then create the various cutaways to subtract from that. Now, what this particular user did when they created this particular wheel, and it wasn't myself, but anyway, the wheel itself started off as a 2D sketch. Now, one key element of Fusion that you may or may not be aware of is the timeline across the bottom of your screen here. Now, what the timeline does is it captures the process of creating that particular component. What I'm going to do now is just quickly run through with you a couple of things about the timeline. So the timeline itself will only record the information if you have a particular setting switched on to capture the design history. Now, there's 2 ways we can turn this on. And look, I would encourage you to have it switched on at all times, because obviously if we do that, we can always come back and edit any of these features. So you'll notice with the timeline, I can move backwards and forwards here. I'll come back to this in a moment. But basically, if you right click on the part name in the here, you'll notice we've got this option, do not capture design history. Now, what that particular option does is Sorry, I'll just give my internet a second to catch up there. I hope that's coming through okay. Dex, can you just give us another sound check? Is that coming through okay? And you can see what I'm doing here?
Yep, that's still coming through, John.
Oh, good. Fantastic.
Yep.
Thank you. Okay, so yeah, basically with the capture design history option, what it's going to do is record all of the different options in here as we create different features in Fusion. Now, if I turn that off, Fusion will no longer capture the information and put it into the timeline. Okay, so you'll get this little warning message to say, if you turn this off, you will lose the opportunity to be able to come back and edit the features in the timeline later on. That's probably the one key thing about Fusion when you start out that's really, really important to know. So that's one way of turning that off. Now, if I turn it off, you'll notice my timeline disappears altogether and I no longer have the opportunity to go back and make edits in that sense. All right. So I'm going to turn that on again. I'm going to turn the capture design history option on again. Notice what's happened. The features that I had here have actually disappeared from my browser. Now, that's not what I want to do. So I'm going to use the undo option to go back a couple of steps and get that back. So just remember, with any new software, one of the most valuable buttons is undo and redo. So when you're learning anything new, being able to go backwards and forwards is really, really valuable and obviously quite important to us. If you make a mistake, you can always go undo or redo, depending on what you want to do. One other very important part of the user interface as well, which I'd like to just point out, up in the top right of your Fusion screen, we've got an option up here where effectively we can, up in the top right, you may see your initials or your name or basically your Autodesk login information. Under this area, we've got this preferences option. Now, preferences is a really good place to become familiar with how Fusion behaves effectively and some of the different settings that we've got in here for each of the different modes. Now, I'll explain the modes to you in a moment, but basically in here, you'll notice if I go to the design environment, I can actually turn my design history on and off in like a global setting here. Okay. And again, another really valuable piece of advice that I was given years ago was if ever you're learning a new piece of software, always just zip in every now and then and have a look at some of these options, read through these options. It might sound a bit of a boring thing to do, but you'll actually stumble across things and think, is that where I can change the information about the rendering processes? So actually going through some of these preferences, guys, is really, really valuable for working within and learning any new software. Okay, so yeah, some of these aspects really, really valuable. So again, under your name in the top right here and preferences, okay, you've got all of the options for different things that you might like to set. For instance, you can reverse the direction of your scroll wheel if you'd like. So if you want to zoom in and out in the opposite direction to the way your scroll wheel works, there's the tick box for that. And you'll find, look, these options will all sort of make sense after you start using Fusion for a little while. And I'm sure you'll find it valuable to be able to work through that. Okay, so what I wanted to show you was perhaps one other method. Like I said before, when we start creating a part, you may choose to make this particular wheel from a cylinder shape. And we're going to use some boxes in a moment to model up our little plate part, this part here. But just to quickly show you one of the other methods, in this particular part here, I can drag my timeline marker, this little sort of funnel looking icon. I can drag this along and basically watch how this part was created. So effectively, the one other way that we could create this wheel is to actually draw the cross section of it like I've done here, and then we could use the revolve tool to create a wheel. All right. So basically what I've done a 2D sketch of this profile, and then effectively I can revolve it around this axis and create my wheel shape. Now, in most CAD systems, especially anything 3D, we work with what we call a Cartesian coordinate system, where we have X, Y, and Z axes, which is what these little icons here are representative of. So I've effectively revolved this I shape, you might call it. It's a bit like a capital I guess. And I've revolved it around the Y axis using the revolve command. So basically that would be one way of creating our wheel. We could simply draw the sketch of the profile or the cross section, if you like, and revolve that around any one of the axes as we'd like there. Okay. So that's one way of creating a part. And basically the way Fusion works is it pops up a dialog here where we can go in and make changes. So if we only wanted a half section of the wheel, for instance, we just change the angle of the rotation or the revolution in this little dialog. So there's quite a lot of options here as to how this behaves. And we don't have time today to go into all the various details, but there's quite a lot of other things we can do when creating this sort of a shape, if you like. So quite quick and easy, though, to create a solid shape, which incidentally, as soon as I do that in Fusion, I can actually now go and assign a material to this particular part, and then we could pick up how much the weight of that particular wheel is, or any of those sort of bits of information. So there's a lot of different things inside the Fusion workspace that are done in the background. So as soon as I create a solid shape, Fusion knows that that solid shape has a mass property. So in here, I've got the option to go into properties, and we could have a look in here, the area, the density, the mass, the volume. And again, this has been set up by default with thermoplastic resin. So there's all of your engineering data about the wheel. So you'll find there's quite a lot of engineering data in here about moments of inertia and a range of other bits of information as well with regard to the origin and the center of the mass and all sorts of different information that's calculated in the background as soon as I create a solid shape. Okay, so put simply, that's how we can create components as well, just simply by working with and working through our process to create our little wheel design. All right, let's go back now to creating our little plate. As I said, I'd like to model this particular part up. And like I said, if you've got Fusion there, feel free to tag along as well. So I've got a bit of a drawing here. So like I said, we're going to start off with a box that's 135 by 78 by 16 millimeters thick. Okay, so I've just got a blank file here that I'm going to start that particular process with. So under the Create drop-down, you'll notice in here, like I said before, we've got the option to create all of these different shapes. So I'm going to create a box, and in actual fact, I'm going to put my box on my XY plane. So when we start out in Fusion, Fusion prompts you and says, what plane would you like your box to start on? So I'm going to pick this plane here. Now, how do I know this is the XY plane? Well, effectively, the little cube up in the top right corner tells me that the Z-axis is upwards, so the blue, and this is actually an international color standard. So blue is our Z-axis, green is our Y-axis, and X is red. Okay, so the X-axis is red, the Y-axis is the green one out here. So if I click to create a box on the XY axis, I simply click on this little yellow square here, and Fusion will say to me, okay, whereabouts do you want to place the first corner? Now, what you will notice if you're able to see on your screen, similar to what I've got, you've got a little marker in the middle here, which indicates the 000 point of my CAD file. Okay, and what we're going to do is start our little box at this point, and we said it was 137 by 78 millimeters. Sorry, I don't know that I've got that quite right. Let me just go and have a quick check. Sorry, 135 by 78 millimeters, okay? I'm going to just jump back into here. I lost that command, sorry. So I'm just going to go box again, start the box and pick here. So it's 135. So I can just type in these dialogues and then I can switch to the other dialogue by hitting my tab key. So I'm going 135 in the Y direction and I'm going to go 78 in the X direction. Okay. And if I hit enter now, Fusion then will prompt me for the next piece of information. And what I want to do at this point is tell Fusion that the thickness of my block is going to be 16 millimeters, I think it was. All right. So we've got a box now that's 78 long, 135 wide, and 16 millimeters thick. And we can just pick OK to that. All right, so I've got a box here. I'll just double check those dimensions. So yes, it was 16 millimeters thick and it's 78 by 135. Now look, really there's no set order that we need to create things in this sense, but what we're going to do in this little example now, we're going to go and draw a rectangle on the face to create this little 4 mil cutout here. So it's 48 millimeters wide and 44 millimeters in from one end. So we're going to create a little cutout in the bottom of our, so this little shoulder underneath here, if you like. We're going to create that little cutout as our next step. Now what we should do, we should actually go and save this file before we get too far. Basically, when I click save here, you'll notice that Fusion by default will put it in whatever folder you've got open in the data panel over here. So I've got this wheel assembly folder open and I'm going to call this particular part mount plate. Okay, so we're going to call it a mounting plate and I'm just going to save that. Now I mentioned earlier on that we can actually operate away from the cloud and effectively not save our files up to the cloud. So just quickly I'm going to jump away for a second and talk about how we do that. You'll notice up here in your data panel, you've got a little clock icon. Okay. Now this little clock icon is quite valuable, and the important thing to notice in here is that I'm currently working online. But if I was to click this and turn it to working offline, Fusion would then cache the files that I've got open to my local drive, and in actual fact, I would be able to continue on working from my local drive. So we can work offline for a period of 21 days, I believe it is. Certainly that's what it was when I last checked. But basically, yeah, you can work offline. Fusion will want you to reconnect to check that your license is active and a few things like that. But basically, we can work offline for a period and continue to create our models as needed. Okay. Now, if I wanted to save this particular part to my local drive, under my little file drop down here, I've got an option to export this. So I can export it out to my local drive. So you can see here, I can save this into a location on my C drive. And as you would expect, we can browse and pick up wherever we would like to place those files in our C drive. We can also export out as a range of different formats. Now, this is quite important, especially for people that are interested in 3D printing, for instance. We can go and export our files out as an STL. So we could export this file as a .stl and then send it to a 3D printing device to create this particular file. We can also export out to a range of other formats, including DWG for use with AutoCAD. We can export out as an inventor file. You'll notice in here we can export out as SAT and STEP and IGES and a range of other types of files as well that are generic file types used within the CAD industry for sharing data. Okay, we need to keep moving along. This webinar is supposed to only be an hour long, so we haven't got a lot of time left. So what we're going to do is go in and do some other modeling processes, just to give you a bit of an idea. And I guess this is what we're talking about here is fairly general stuff, but obviously we do run training on the Fusion application. I conduct quite a bit of training on the Fusion side of things, and if you want to go into this in more depth, we do run a 3-day course fairly frequently. If you want to sort of develop your Fusion skills further, where we go through a bunch of exercises like this. And by the end of it, you'd be confident to create fairly complex assemblies, be able to do some animations, creating drawings and different things as well within that particular training course. What we're going to do next, though, is we're going to create some fillets. So in here, we've got the option to create fillets. And one other thing with Fusion, it does operate with quite a lot of hotkeys. So you'll notice there, I can either pick the fillet dialog here, or I can just type F on my keyboard. Okay. F for fillet will start the fillet command. Now in the fillet dialog, you'll notice what we can do is we can go in and just start picking edges, and Fusion will allow me to pick as many edges as I like. So we're going to pick these 4 edges. We can even pick through our part if our graphics card is working happily. Mine's perhaps chewed up a little bit by the Zoom meeting info, but so I'm going to pick to pop in we're picking 4 edges here, and I'm going to do a 12mm fillet radius. Okay, so we've done a 12mm fillet radius. One of the really clever thing that I will just show you in Fusion is that I can pick those 4 edges to have 12mm radiuses. I could go and pick some other edges now and set up a different size, all within the one fillet command. So for instance, if I wanted a 3mm fillet on this edge, I can have multiple fillet features within the one entry in my browser, okay, or in my timeline. So even though I've got 5 edges selected here, most people would be aware that in most software you would need to add another fillet feature, which means your timeline becomes hugely long and often quite unusable. So so that's basically adding a fillet. We can just add a fillet there, and I'm just going to go in and we'll actually remove that one. So I'm just going to close out of that. That was just a bit of an example of adding other fillets. Okay, what we're going to do next is we're going to now go in and, like I said, do that little cutout in the bottom of our part, which I think I mentioned earlier. In here is 48mm wide, and it's 44mm in from the end of the part. So what we're going to do is jump in here, and I'm going to do a sketch on this face of my part. And the way we do that is just pick the new sketch option and then select the face. And what Fusion does is it spins my block around, if you like, so I'm looking square on it. Now, if I rotate away from square, I can just very quickly go and click on this little look at button to bring it back square to the screen. So the little look at button there in your sketch palette, there's quite a lot of handy little tools in here, again, that do some very valuable stuff for us. But basically all I'm going to do, I'm going to draw another rectangle, and I'm going to simply draw a rectangle picking one side and then the other side. So if you start your rectangle tool and then pick the left-hand side of your block and the right-hand side of your block, and we're now going to add some dimensions. And remember we said that this particular little cutout is 44mm in from the end, and in actual fact, the length of the cutout was 48mm from memory. All right, I'm confident that's right. So, yep, 48 wide and 44 in from the end. So basically what I've done is I've just drawn a rectangle, 44mm in and 48mm wide. It's the same width as the part, and you'll notice when I click here, it automatically snaps to the previous geometry on my part file. So what we're going to do next is just finish that sketch, and I'm going to do an extrusion now. So this little option up here And again, you'll notice the letter E in brackets means I can just type E on my keyboard to get the extrude dialog box up. Okay. And what we're going to do is we're going to create an extrusion in this part, and we're actually going to do a cutaway. Now, Fusion has these really neat little tools where I can grab this arrow and change the depth or direction of my little cutout here. So I can either make it a post or I can do a cut-in shoulder, which is actually what I want to do at this point. So I'm going to go in here and set the distance at -4 millimeters. That was the cut depth of our little recess in the bottom here. And I'm going to pick OK to that. You'll notice that it's automatically switched me over to do a cut. So it's cutting away material. And I'm just going to pick OK to that. All right, what we're going to do next is we're going to do very similar on the top, only we're going to draw another rectangle and do a cut down here. So the size of the other rectangle on the top face is, again, it's a 4 millimeter step down, but it's 61 millimeters wide, 37 in from the end. So effectively what I'm going to do now is do another sketch on the top face this time and another rectangle. And I'm going to just draw another rectangle, a bit like what I did before. And again, add some dimensions to this particular part. And we're going to make this, sorry, so it's, yeah, it's 37 and 61. So if I want to edit this dimension, I just double click on it again. So it's 37 millimeters in and it's 61 millimeters here. Okay, we're going to finish that sketch. So effectively now what I'm going to do, I'm not going to do an extrusion of this part. I'm actually going to cut these two leftover pieces out. So what I'm going to do now is do an extrusion, but this time I'm going to pick this part and change the direction downwards. And again, it's a 4 millimeter step down. Okay, so we've got a fairly basic shape there, but hey, we've in not more than 10 minutes, we've done a pretty good job of starting out with what our plate looks like. The last thing we want to do is really just pop our holes through our plate. And again, I think, so they're 12 millimeters, we'll just make them 12 millimeters in all around. And what we're going to do this one is I'm going to do another sketch, and I'm going to, in actual fact, there's a couple of different ways of doing holes as well. Now, if I wanted my hole to be concentric to my radius or my fillet here, I could just use the hole command and simply pick to put a hole on this face. Okay, and then if I pick this fillet, Fusion will automatically make it concentric or at the center point of that fillet. Now, I think the holes were 10 millimeter diameter or something. Okay. So again, I could go through and simply pick to place holes at these particular junctions. Okay, so if that was the case, now my holes aren't equi in. You might have noticed they are 11.5 and 12. So what I would normally do in this instance is just do a sketch on this face. So start a sketch here on this face. And then I would put a point. So you'll notice in the little drop down here, we've got the option to place a point. So creating a point. All right. And effectively, I can put a point here and then dimension that point in from the two edges. So it was 12 millimeters here and 11.5 in the other direction. Okay. Now, what I could do at this point is I could go in and create 3 other points. We could pattern the points as well. So we could actually pattern the points if we wanted to. Down in the the create option, we've got the option for a rectangular pattern here, and we could go in and use a pattern tool to do that. The other way to do this as well is to create a point, and then we can align the point using what we call constraints. Now, we don't have time today to go into all the details on constraints, but effectively, I can horizontally align my 2 points. Okay, so now I know that this one here is 11.5 millimeters off the base because I've used a horizontal constraint to align these 2 points horizontally. Okay. Now, the other thing, when I'm creating a dimension, if I want a dimension to be equal to another dimension, effectively I can pick this other dimension and apply that one to the distance here. So there's a lot of little great tools like that, but again, be nice to go through all of these today, but and maybe we'll do another webinar shortly on creating objects and shortcuts and tips and tricks for Fusion. So maybe if that's of interest to you, please let us know, and we'll certainly pop that into our program to try and perhaps do a webinar based on that. So again, I'm going to do a horizontal constraint between here and here, and I'm going to do another constraint this time between here and here, and this will align this one vertically now with like so. So now I've got my 4 center points. I'm going to finish that sketch. And again, like I said before, we would just pick our hole command. And you'll notice now I can just go around and pick my 4 holes, or my 4 points rather, and place holes at whatever diameter. So again, if I wanted these to be 10 mil holes. Okay, and we can tell Fusion that we want them just to be through holes. They don't need to have a depth value. So in here, I've got a bunch of different options for how I would like the holes to behave, whether they're counterbore holes, countersink holes. If we go in and pick a threaded hole, for instance, a tapped hole, Fusion then says, okay, well, tell me a bit about the thread that you'd like to put in that particular hole. One other really cool little feature with Fusion, if you do a threaded hole, and for anybody that's used a 3D CAD system before would probably be aware that the actual thread itself is a bitmap image that's just put onto the surface of the hole, so it looks like it's threaded. However, in Fusion, if I was to come back in here, you'll notice I've got a little tick box to say I want a modeled thread. Really valuable if you're going to be 3D printing your threads. And you'll notice now that in actual fact, that's modeled up the 60-degree helical form of that particular M10 thread. So yeah, that's a very, very handy little tool. So what I did then, guys, sorry I jumped ahead a bit there. If I want to make a change to the size or whatever it might be, if I want to change these to a metric fine thread, I can just double click down here on that feature in the timeline to make edits to any one of these features. Okay, so very, very quick and easy to model items, and I'm just looking at the clock and noticing we're running out of time. So look, we're not going to go into that in any more detail, but like I said, in our training courses, we obviously go through all of these functions step by step. We generally would spend perhaps an hour or two exploring all the functions within the whole command. Today, we've done that in about 3 minutes. So we're not going to go through that in any more detail today, though, in that sense. So the last little aspect of part design that I'd really like to talk about with you is the free form options. And this is something that's quite powerful with Fusion. For anybody that knows anything about T-splines or NURB surfaces, you'll know the complexity that's involved. So I'm just going to open a new design just to give you a quick, it's going to have to be a 2-minute rundown on this, otherwise we're going to run out of time. Basically, this option here is where we can create a free form model. So if I click in here to create a free form, what I can do is actually tell Fusion that I want a free form shape, and it wants to be 100 by 100. And basically what it does, it gives me what's called a T-spline. Now, this particular shape looks a bit interesting in that you're probably saying, well, that's not a box, it's, but hey, what actually is it? Well, it's a free form feature that allows me to basically do what we would maybe refer to as like push me, pull me modeling. Now, if I click on here and go modify the form, I can now select a face, and you'll be pretty impressed with this, I think. We can just drag that face and offset it by 50 millimeters, for instance, just that one face. So we can do quite a lot of functionality. And look, this is something that's quite a clever tool in the software these days. So if you wanted to create a fancy wing mirror or something like that for your Ferrari, you could go in and create your own shape of whatever it might be. Now, there's a whole bunch of these. I just picked a box, but you can do this with a surface. You can do it with a cylinder, a quad ball, and also a face. So lots of different options there, guys, for free-form modeling. Like I said, you can push and pull this in any direction. And again, obviously, with the advent of 3D printing, I could actually now just go and save this shape out and run it through my 3D printer because that's the shape of my new, whatever it might be, my new widget. So yeah, we can just basically push and pull either a face, or in actual fact, I can select a point as well. So we can do this sort of thing. So we can push and pull basically any shape. And again, there's a lot of computing power going on in here and hundreds of different options here as well for how we would like to edit the form. So again, really, really valuable tools if you're into to free-form artistic design. You may like to look into that. Obviously, us engineers tend to think about things more in the sort of how hard it's going to be to make for a starter. But obviously with 3D printing, that whole sort of concept and principle has changed as to how hard actually it is to manufacture something compared to what we can actually do in that regard. So look, I'm sorry we've basically run out of time, guys, and but I hope what we've shown you today gives you a bit of an interest in grabbing a download of Fusion. If you're in a college type situation, or you're a teacher or whatever it might be, we do run these courses specifically for teachers as well. So just setting up some data management principles and things like that. But basically the concept with Fusion is that it's a relatively easy to learn software. It's probably, I think it's actually considered one of the easiest to learn because of the way the interface is and with your data management concepts here. One other thing that I didn't mention that I probably should just quickly, here are the 7 different modes that are available within Fusion at this point. So we've got options to design components, we've got generative design, and I did have some other slides on this. We're going to have to skip over them for the sake of time. We can go in and render items, we can do animations and exploded views. We can simulate stress and product flow and different things like that within Fusion as well. Here's our CAM side of Fusion, so we can go in and do some tool pathing if that's of interest to you as well. And lastly, down here, we've got the option where we create drawings, as I did with this little example here. So what we'll be doing over the next couple of months is running other webinars, not unlike this, where we go through different aspects of the Fusion interface. We'll certainly next time be looking at assembly design and actually designing components in the context of an assembly is the plan. We'll then do another one on creating drawings and working with drawings, and perhaps some of the other simulation tools as well if we get time. So I hope you've enjoyed what we've talked about today. Just a couple of other quick slides. Like I said, I was going to go through a bit of an example of what we call generative design, where basically we design something and then tell Fusion to actually reduce the weight on the design but keep the strength and the stiffness the same. Here's an example of a sort of a clapis that we actually made here at A2K, and we printed this in stainless steel on our Markforged 3D printer. So yeah, basically we modeled this component in Fusion, we ran it through the Fusion interface. It gave us all these different iterations of the model which would retain the strength and stiffness, but reduce the weight by, say, 70% or 50% or whatever it might be. And basically, we can then just go and 3D print that particular item then, which is exactly what we did here. So this is a component made out of 17-4 stainless steel that we printed in Parafield here in Adelaide. And yeah, it effectively has the same physical strength as the part on the left, but is about, I think it was 40% lighter or something we set in those particular parameters. This is actually being used quite widely now in industry. So here's another example from General Motors where they had a seatbelt bracket for one of their vehicles in the US. And basically this component here was replaced with a 3D printed component. It was 40% lighter and 20% stronger. So this is what's sort of the future of things. Obviously, they've been using this technology in aerospace for some time to reduce weight and to increase structural strength and things like that. But now we're seeing this with the availability of 3D printers and things like that. We're seeing a lot more of this taking place in general engineering as well. So look, we'll stay online for 5 or 10 minutes if there's any questions. Thanks again for joining us. I hope you've enjoyed the session today. Like I said, we will be doing more of these sessions, and please do reach out if you have any questions or queries. If you'd like to know when our next one's going to be, you'll find upcoming events at this particular link. So a2ktechnologies.com.au/events will list all of the upcoming webinars that we plan to do. So thanks again for watching. It's been a pleasure to have you along, and I hope you've learnt a few things about Fusion. Please do get in touch with us at info@a2ktechnologies.com.au if you'd like more information. Or like I said, in the chat window on your Zoom panel, you'll notice there's a little Q&A item there that you can pop a question up if you have something that you'd like me to work with. So Stephen, thanks for your question. Can you import a Fusion 360 model into Revit? Not at this point, I don't believe. However, we can take it via Inventor straight in and then into Fusion. And then into Revit. So thanks for your question, Stephen. Basically the concept is that Fusion files save out with a format. You could certainly bring it in as a non-native file, but if so, obviously step. I think Fusion will import a step file. I probably shouldn't say that too. Maybe I need to double check that, but I'm not a Revit guru, I'm sorry to say, but I'll certainly check that and come back to you, perhaps, Stephen, on that one. So yeah, in the panel there, guys, you'll notice there's a Q&A button on your Zoom panel. If you'd like to ask any questions, feel free to do so. You're welcome, Sergio. I hope you enjoyed it and learned a few little things about Fusion. Fusion's a great piece of software, guys, and like I said, it's I think it's really the way of the future because it is so interconnected with the internet. So yeah, thanks again for attending, and all the very best. If you go down the Fusion path, like I said, get in touch with A2K. We can certainly help you with training or yeah, quite a few different options. Good question, Sergio, regarding what's the difference between Fusion and Inventor. So Inventor's been in the marketplace for around 20 years now. Inventor is perhaps, I tend to refer to Fusion as Inventor's little brother, so they are quite similar. And that's a very good question that you asked there. What are the main differences? I guess by default, Inventor doesn't have any cloud enablement in that sense for data management, especially. As far as functionality goes, only time I'd perhaps think about using Inventor over Fusion if I had a particularly large design. So if I was designing a, I don't know, let's say a train locomotive, and it has 10,000 parts in the assembly, maybe I would be a little bit cautious of using Fusion. There's people that would certainly do it in Fusion, I imagine, but I guess just because of some of the tools that Inventor has for large assembly management is probably the biggest standalone item in my opinion. Having said that, a lot of people would still use Fusion to do that. So yeah, absolutely, and very good question, Sergio. What's the differences between the two? Like I said, Inventor doesn't have cloud enablement as such, as far as using cloud applications. The good thing about Inventor, as I showed there in the demonstration, is you can bring your Inventor files straight into Fusion, and they will operate quite happily within Fusion. So you're not going to lose any of your history as such. It's yeah, a very fluid workflow because they're both Autodesk applications. So, any other questions before we wrap up and conclude for the day? Sorry, we were limited to an hour there, so apologies if I've taken more of your day than I should have. But I hope you've learned a few things and picked up a few little tips perhaps that will help you work more efficiently with Fusion in the future. So